Okay, we're going to be looking at the osteology of birds and marsupials. So in this first picture, what we're looking at is a faraway view of the skeleton of a chicken. So just some general things here, like for example, the maxilla and the mandible. Moving down here, what we see are the cervical vertebrae, and we see that this is a pretty elongated neck. Moving further down, here, what we want to pay attention to is the clavicle, which you cannot see it here, but we're going to see it in some other pictures, is that the clavicle is actually joined in the center on a lot of birds, and it's called the furcula, and we call it, in everyday talk, the wishbone. And so we're going to see that in some slides that are coming up. Next, we want to look at the pectoral girdle. And so notice that here we have the coracoid, and that's a pretty large looking coracoid right there. And we see that it articulates right here with the sternum. And look at how big and broad this sternum is right here. Okay, so imagine now having a sternum that's that big blady sternum. Compare that to a human sternum and ask yourselves why a bird needs a sternum that is so broad like that. The answer is that the muscles will be attaching to either side of this blade. And which muscles are we talking about? Well, it's going to be a group of pectoral muscles, very, very thick, powerful pectoral muscles that will be controlling, of course, the wing. And so when you think about, for example, ordering chicken breast versus chicken leg or something like that, you know, based off of food experience, that the breast of a chicken is going to be very, very meaty. There's going to be a lot of muscle there. And that muscle is, of course, the powerful muscle used for flight. So now we want to see over here the actual pectoral girdle. Continuing here with the humerus, as you would expect, you have the humerus there. Notice that you also have that humerus articulating over here with the scapula. And you can't see it too well here, but the scapula on a bird is very thin and light. So it's not a blade-like scapula like you see on a human. It's actually a very thin bone. In general, what birds want to do is they want to lighten their load. They want to decrease their weight for flight. And so what we see is that they have certain structures that basically lighten their weight. And so the scapula being very thin there and light on their back serves that purpose. Continuing here with the humerus, so this is basically the joint of the elbow of the bird, and you have the bones that you would expect. In parallel, these two bones, the radius and the ulna, in parallel right there, as you would expect, as you would have it in a human forearm. And so then that means that over here, that's where the wrist would be. And so that's where the carpals would start. But here what we see is a very modified bony structure after the wrist in birds, and that's because of the wing. We have to create the wing, and so in order to do that, we have to change the carpals. And so right here, this bone, this carpometacarpus, notice that is a carpal, but look at how long it is. So this carpal is very modified, and it's a long carpal bone because, of course, we want to extend the wing. We want the wing to be very long, and so to extend it, those carpal bones are modified. If you looked at a human set of carpals, they would all be these short, pebbly bones, but in this case, it's this longer bone to extend the length of the wing. And the phalanges are doing a similar thing where they're kind of stacking on top of each other to extend the wing span. We have lost some phalanges, so notice there is this digit 2 right there. There's a digit 3 and 4, which look like they're stacked on top of each other. So very modified here in order to extend the length of this limb. Okay? So digit 2 refers to the index, 3 middle, and 4 ring. So just remember, when you're looking at your own phalanges, your thumb is phalanx 1, your pinky is phalanx 5. And so we've also lost some of these phalanges through evolutionary time because of lack of need. Let's look further down here. So what we want to look at is, of course, the vertebrae are going to continue right down the backbone of the animal. But let's look at the ribs. So here what we have are a set of ribs called vertebral ribs. And so the question is, well, what's going on here with the vertebral ribs? First of all, they do have these interlocking uncinate processes, and you can see them right here, these structures that kind of poke out of the ribs. And these structures are for protection of the thoracic area of the animal, but they're also for muscle attachments. And then there's another set of ribs called sternal ribs, which you can see them articulating with the vertebral ribs right there and there and there, and they articulate right there, but then what they do is they go and make a connection with the sternum. And so basically 2 sets of ribs joined together, giving that characteristic shape of the thoracic area of the bird. Now, this is a remnant from its dinosaur past. And when we look at dinosaur skeletons, what we see are similar rib structures, and that's where this is evolutionary linked to dinosaurs. Further down, we want to look at the pelvic girdle. So, of course, the ilium is going to be the largest of the hip bones. And then what we want to look at is that parallel arrangement of the ischium and pubis. And if you recall, when we talked about dinosaurs, we did say that there were 2 classes of dinosaurs, the Saurischian line, which is where birds actually come from, but then there was the Ornithischian line, which birds are more similar to nowadays. The Ornithischian dinosaurs were the dinosaurs where the ischium and the pubis are arranged in parallel to each other, and that's how modern day birds are as well. From the socket, right here, the hip socket, it's the bone that you would expect, which is the femur, and then here would be the knee joint. Now notice here you have the fibula, a very thin bone. We're going to see a better picture of this coming up. And then notice this term right here, okay? It's called a tibiotarsus. So in the human, you have a tibia and a fibula. In a bird, you have instead of a tibia, it's called a tibiotarsus. Now, why are we using that term instead of just calling it a tibia? We're using this term because at the bottom of the tibiotarsus, there are some tarsal bones that have been fused over evolutionary time to the bottom of the tibia, forming a kind of bone that is a combination of several bones down there. And so that's why it has this characteristic name. So please make a note of that. So then if that is the tibiotarsus and the fibula, then this right here should be the ankle joint. And notice here, again, what we have is an extended tarsal, similar to what we had in the carpal. Right here, we had the carpometacarpus, right? And so down here, what we have is a very similar bony arrangement. And this one, this elongated tarsal, is known as the tarsometatarsus. Tarsometatarsus. Okay, so if the bird is looking in this direction, then this right here would be its left limb. It looks like the right limb is not being depicted in this picture. So let's go ahead and look at the rest of the lower limb. Notice we have phalanx 1 in this case, phalanx 2, so this would be, for the human, it would be thumb, index, 3 is middle, and 4 is ring, so it looks like we've lost the 5th, or the pinky one, right? So again, this is the left limb, so it's kind of moving this way in order, so make a note of that. And we want to see what happens with the vertebrae after we get past the pelvis. So notice that we do have these vertebrae that continue here. These are the free caudal vertebrae, and they end with this very characteristic tail vertebra called a pygostyle. Now this right here is the bottom view of that hip structure, and so you can kind of see how these vertebrae here, these segmentations, are continuing down the central axis of that. Here we want to look at the skeleton of the bird as it relates to function. And so let's start with the upper limb. We see that the limb is extended here, and notice how we have the humerus, the radius and ulna going in parallel here, and then again this carpometacarpus extending that limb even further. So what does that do? Well, that allows for this wing to be extended further out this way. Just notice how all of this wing part, right, all of that is due to what is after that wrist joint right there. So by having that carpometacarpus and those phalanges stacked together, we have added a bunch more wing area for the bird. Regarding the neck, notice that the cervical vertebrae are large, and there are several of them stacked, and this is going to give a lot of mobility of the neck, right? And so we want this bird to be able to move its head around quite freely. Why is that the case? Well, the upper limbs are for flying. If the upper limbs are for flying, that means that they cannot grasp, and so a lot of the grasping will be with the beak, and so we need to have a lot of movement of the head in order for that beak to be effective. And the other thing that we want to do down here in the lower limbs is we want to extend the lower limbs as well. We want to grasp with the lower limbs if we're flying with the upper limbs. And so remember, this is the knee joint here, and this would be the ankle joint. And so notice what we've done is we've extended the leg even further this way with this extended tarsal bone, which extends the grasping limb even further and allows for more movement, right? Because you're going to have a movement at the hip joint, you're going to have movement at the knee joint, and also quite a bit of hinge type swinging movement at the ankle joint, and that gives a lot of movement for a lower limb, which is a grasping lower limb. And if this is a predatory bird right here, just think about it this way: the claws are going to be sunk into the talons are going to be sunk into the prey, and the beak will be picking away at the meat. Here we're looking at the skeleton of a chicken, a picture of it in this case. And so we see a lot of good detail here in this picture, well labeled for us. So one thing to notice is that a lot of birds have a bony, structural, circular, sclerotic ring in the eye socket. So not all birds have this, but several birds do, so make a note of that. Notice these vertebrae being quite large, and of course quite a few in number. Again, this gives a lot of mobility of the neck and of the head. The reason why birds are going to need a lot of mobility here again is because, of course, their upper limbs are not able to grasp. So what this picture shows, which is really nice, is that first of all, we can look at the furculum right here, and what we see is that these are the collarbones. That if you notice, they are connecting right there, and that's known as the wishbone, right? And so we oftentimes pull that out before we start eating, and we make a wish. The other thing that's nice here is that the wing is folded on the dorsal side, and so what we see here is the humerus, and notice here you have the radius and the ulna that are in parallel there, but notice how they're kind of making this, these three bones are now all in parallel in order to basically put the wing away and fold it when it's not being used. So that means that this right here is the elbow joint. That means that this right here is the wrist joint. And so here is the carpometacarpal, and then the phalanges going right there. So this is kind of the wing tucked away, if you can follow that, and kind of how it winds and it zigzags in order to fold it on the back of the bird. So then the other thing we can see here is that we do have those vertebral ribs making linkages there with the sternal ribs at each articulation. For the lower limbs, a term that is often used for the ilium, the ischium, the pubis, and the sacrum that is fused in the middle of all that, a term that is describing all of those bones together is known as the synsacrum. So when you see the word synsacrum, that's what it means. It's all those bones fused together. Okay, so you still are going to have the bones like the ischium and the pubis in parallel here, but it is all fused together, and oftentimes we just refer to it as a synsacrum. Over here, what you see is the femur coming out of the hip joint, and there would be the knee joint, and then here, notice again, you can really see how thin that fibula is, right? Very thin fibula, and a tibiotarsus, which is the tibia, also with tarsal bones fused at the bottom, and then this elongated tarsometatarsus, giving this limb this extra extension. The phalanges, again, are going to be with the 1, 2, 3, and 4, and losing the 5th one. This is a skeleton of the kingfisher bird, and for this picture, really what we want to see is variations of these bones in different types of birds. And so the great thing here is, for example, the keratinized beak, which can take so many different shapes and sizes in different birds. So in the kingfisher, you can see how big that is. The other thing is that, again, notice the synsacrum here, a term that refers to all the different hip bones kind of fused together. And here is the keel of the sternum, the sternal keel, showing that big blade of a sternum right there. Notice the furcula is well depicted here. You can see that there is a collarbone right there and a collarbone right there, and they are connected right there, making that furcula wishbone. The carpometacarpals, extending that upper limb to the phalanges, and if you look at the lower limbs, you've got the tibiotarsus again, and the tarsometatarsus extending the lower limbs, and then the phalanges with the hallux, meaning the thumb, or phalanx number 1 right there. You can also see the vertebral ribs joining with the sternal ribs at these articulations right there, and you can see the uncinate processes of those vertebral ribs that we saw in the previous picture. In this picture, we want to see the details of the bones of the skull. So this right here is an ostrich skull, nice and big with bones clearly seen and labeled. So what we want to notice here is the keratin on the beak. Modern day birds do not have teeth, so they create the structure of their beak with keratin. And what you want to notice here is the premaxilla bone and the arrangement of the premaxilla with the maxilla is not what we've seen in other organisms, because they're kind of making this angle right here with each other. You can see they're kind of diverging here, so that the maxilla is going this way, right? And the premaxilla is going up that way. So let's follow the premaxilla first. We follow the premaxilla, we run into the nasal bone. You can see that right there. And the nasal bone, if we follow it upwards, the nasal bone is going to run into the frontal bone, which is where you would expect it. The frontal bone, if we follow it, it's pretty big in birds. We follow it back this way, and then we run into that parietal bone, which is also really big, making the back part of the brain case. So now let's follow the maxilla. If we follow the maxilla, we follow it this way, it runs into the jugal bone, right? So the jugal bone is making this bar here, which is a very characteristic structure in birds, that bar that the jugal bone makes. And the jugal bone is going to run into, right here, that quadrate. Now notice this quadrate right here. This quadrate can swing forwards and backwards, and we talked about streptostyle in lecture, where basically the quadrate has an ability to swing out, and that's going to give quite a bit of kinesis of the skull there, ability for this jaw to move forwards and backwards. Then when we want to look at what's going on underneath, what we see is the dentary, which is the lower jaw. So the maxilla is the upper jaw and the dentary is the lower jaw. And so basically this area right here would be the opening of the mouth sandwiched in between those two bones. Now when we're thinking about animals that do have teeth, remember that the maxilla has the upper dentition and the dentary has a lower dentition. Modern birds that is, don't have teeth, and so we're dealing with keratinized beaks here. The dentary, if we follow it backwards this way, we run into the prearticular, and then over here what we have is that angular bone making that angle, and here is the temporomandibular joint of the bird, which would allow for the mouth to open and close. The other thing to note about bird skulls is that they have become very light. In general, bird skeletons have a characteristically light build. And so these are diapsids, but you cannot really see the two fenestrae very well, because basically there's been a lot of losing of bone tissue throughout this skull in order to lighten the load. So notice how wide and open all of this is, right? So you're losing a lot of mass there by opening it up, and by losing mass, you also decrease the weight. This is the skull of a rock dove, and here what we see is, again, this similar structure that we saw before, with the premaxilla going one way and the maxilla kind of going another way, making this angle here at the tip. And if we follow the premaxilla, just like we saw before, we run into the nasal bone. And if we follow the nasal bone up, as we saw before, we run into the frontal bone. If we continue to the back of the skull, we run into the parietal bone. And what you see here, which we could not see in the previous picture, is of course the occipital bone, which will give rise then, if we follow it downwards, to the cervical vertebrae moving down. Another thing to note here is very clearly that sclerotic ring, which is a bony structural structure that basically reinforces that eye socket. And now let's follow the maxilla this way. There's the maxilla. And so we follow it backwards and we run into the jugal. You can see that bar being formed right there with that jugal right there. And the jugal runs into the quadrate. And then if we look at the lower jaw, again, we start with the dentary. We move backwards. We see that prearticular. Pre meaning before the articulation. Articulation means where the movement takes place. And then here at that angle, we see the angular, and there is that temporomandibular joint, which would allow for the opening and closing of the mouth. This is the skull of a wild turkey. And again, we want to look at the same bone structures and follow them on another type of bird. So again, we start with the premaxilla and the maxilla and their relationship, forming that triangle right there. At the tip, we follow the premaxilla and we run into the nasal bones. Nares just means the opening for the nose. And if we follow the nasal bones backwards, as expected, we run into that frontal bone that is in between the eyeballs. And if we continue this way to the back of the skull, we run into that parietal bone. So now we want to follow the maxilla this time. If we start with the maxilla and we follow it, we see that there is that jugal bar that we expect. And that jugal bar right here, we see that it runs right into the quadrate, which again is streptostylic, which means it can swing out, giving kinesis to that jaw. And then we want to look at the lower jaw with the dentary, and we follow it backwards. And we see again that we have that prearticular, pre meaning before the articulation or before the joint. And then here we have that angular, making that corner right there where that joint is actually located. Again, notice that what we have is a great deal of basically open space here, right? So all of that is open space, which lightens the load of this bird. So you see all of this is open. We've lost a lot of bones. These are diapsids, but it's hard to see that it's a diapsid because over time these birds had to figure out a way to lighten. This picture, in my opinion, says it all. Here we want to look at the skeleton of the bird, but we want to look at it from a functional perspective. So here is the prey, that fish right there. And what you notice is that the upper limbs, creating that wing span for flight. But what we lose in the process is, of course, that we cannot grasp with the upper limbs. And so that means that we grasp with the lower limbs. You can see these talons that are perfect for grasping. And what you can really see is the length of this lower limb. And if you think about it, if that's your harpoon, if that is what you are hunting with, then that right there, being so long and extended with that tarsal bone, that tarsometatarsus that is modified, allows for that extra reach in order to get to that prey. And then, of course, we also see those vertebrae that are many in number and large, with obviously a lot of mobility there in the neck, because then what we need is for the head to move around freely in order to pick at the prey. Here we're going to look at an opossum skeleton, and the opossum is our example of the marsupial. And just to be clear, the marsupials and the eutherians split from a common ancestor somewhere in the Jurassic 100 to 120 million years ago. The distinction between marsupials and eutherians is that marsupials have a pouch, where the newborns who are born prematurely can go in and develop within that pouch. They will still be suckling on teats within the pouch, but the difference is that a eutherian newborn will be much more developed and mature than a marsupial newborn. So 100 to 120 million years ago is a long time for these two, even though quite similar to each other, to have diverged and to have characteristic anatomies. So marsupials do have hair, they do produce milk, but there are some differences even with the skeleton. For example, one thing I'm going to highlight right here, which is difficult to see in this picture, but you can see it in some other pictures that I've provided for you in other documents, is that epipubic bone found in marsupials, which you do not see in eutherian mammals. Okay, so real quick, this is just a faraway view of this opossum. The opossum is the American marsupial. Marsupials are all actually originally American, but the kangaroos that we find, for example, in Australia, are because of basically shifts in the crust of the earth where continents got separated, and basically once they got separated, the original marsupials went extinct, but we still do have the American or the Virginian opossum, and that's what we're looking at right here. So first of all, these are omnivores. You can see based on their teeth that they do have these incisors, these quite large canines, and then these premolars and molars in the back, allowing them to eat a wide variety of different foods. What they have that's very characteristic up here is that sagittal crest, very, very prominent sagittal crest up there with on top of that parietal bone, and over here is that occipital bone. So it's kind of running right into that occipital bone on that corner right there. Also, the cervical vertebrae are also quite large right here in the back. All of this is for muscle attachments. And so in order to move that head around, you have very powerful muscles on the neck that are attaching from the cervical vertebrae to the skull. You can see that scapula here, very classic looking blade-like scapula that you do find in mammals. Quite often, these scapula are very similar across mammalian species. You can see the spinous processes, very, very large and prominent, of those thoracic vertebrae, going into the lumbar vertebrae, the sacral vertebrae, and then going into the caudal vertebrae for the tail. You can see that the thoracic vertebrae do have ribs associated with them, and these ribs are wrapping around all the way to the sternum, which is not very visibly seen right here. And if we look at the upper limbs, we have that classic arrangement of the humerus, this being the elbow joint, going into the ulna and radius in parallel, short carpals and long bone metacarpals, and going into phalanges. When we look at the lower limb, again, you want to make a note of the epipubic bone, which is a characteristic bone found in marsupials. You do have the ilium that is being shown right there, the ischium right peeking out right there, kind of hard to see there. And then what we want to look at is that we do have that similar arrangement that we have in humans with the fibula and the tibia that are moving down this way together, if you can see those two in parallel. So here is the femur going all the way to here. There is the knee joint, and then over here is the fibula, and there is the tibia, and then over here what we would have is the ankle joint, and so there are the tarsals all clustered together in there. And then notice that the calcaneus or the heel is touching the floor there, And then you have these metatarsals that are long and going into long phalanges. And why this is important is because we call this type of foot position the plantigrade foot position, which humans have as well, where basically the heel touches the floor as we walk. And so opossums also have this. Other animals, such as cats, for example, lift their heels off the floor so that only their digits are touching the ground. And you also have other examples, such as ungulates, where only the tip of the phalanx touches the ground. So there are variations of how much of the foot does touch the ground. Here we're going to look at the skull bones of the opossum. Let's start on this side. You do have the top view here. You can really see that pre-maxilla right there, and the front as you would expect it to be. And then the pre-maxilla gives rise to the maxilla on the lateral side. On both sides, there's the maxilla. And then over here in the middle, it'll give rise to the nasal bones. Okay, so you can see where over here it's giving rise to the nasal bones. The nasal bones, if you follow them, give rise to the frontals. So there's that frontal bone right there. And there is that sagittal crest that is very prominent. We saw it in the previous picture. It's hard to see how prominent it is here because it is a top view, and that runs into the parietal where the sagittal crest continues. So there are the parietals, and then the parietals run right into the occipital bone in the back there. So on the lateral side, after the maxilla, we notice that the maxilla, we do have a lacrimal bone right here. There's the lacrimal bone. And then on the side, we have that jugal bone, as we would expect, making that zygomatic arch right there, that jugal bone. And the jugal bone runs into the squamosal. And so the squamosal, if you know human anatomy, is like the temporal back here. That is the squamosal, and you have the jugal and the squamosal meeting at that suture right there, making that entire zygomatic arch. And these are synapsids, and so we do see that one single fenestra very clearly right there. Now, from the bottom view of the top part of the jaw, we can really see these incisors over here and the very prominent canines. Remember that opossums are omnivores, so they do have teeth that are very versatile. And then we have 3 premolars followed by 4 molars in the back used for grinding. Over here, you can really see that arch of that jugal bone making its way backwards, and the middle ear in marsupials, just like eutherians, we do have 3 middle ear bones for hearing. The incus, the malleus, and the stapes will be found in there. And then here, what's nice about this is that this right here is the occipital bone, and then it tells you right here it's labeled occipital condyles, and that just means anytime you see occipital condyles, you know that the atlas or the first cervical vertebrae will be articulating right at that spot. And then right there, that hole right there is the foramen magnum. The last view that we have here is the side view. And here you can really see how that premaxilla is shaped. And notice that the incisors are on that premaxilla. That's where they're coming out of. Following the premaxilla, you see that right after it, regarding teeth, is going to be the maxilla. And so the maxilla is where most of the upper jaw teeth are going to be found. there are those pretty impressive looking canines, 3 premolars, 4 molars for grinding in the back. Up above, if we follow the premaxilla upwards, we have the nasal, we have that lacrimal bone right there, pretty small, but it's there, a big frontal bone, a large parietal, all the way to the occipital, and then making that bar or that zygomatic arch, you've got the jugal articulating with the squamosal. Let's look at the lower jaw. In the lower jaw, if we're going to have teeth, we know that it is the dentary. The dentary is going to have the lower jaw incisors, the canines, the premolars, and the molars. And over here, what we notice is that temporomandibular joint right there, that single joint. These skulls are akinetic, so there's not there's not movement in the brain case. There's only one joint for movement, and that is the temporomandibular joint to basically open and close the mouth.